There were so many terms that were used in place of rehabilitation engineering, but the ones that were much prevailing were these two: assistive technology and rehabilitation engineering, the ones that were used more frequently: assistive technology and rehabilitation engineering, right? So in our previous classes we were only saying about these two, right? So these are the slides which defined what rehabilitation engineering and what assistive technology, and we saw different examples, the history, how different regulating bodies came into play, how different act came into play, different case studies, right? We saw all the basics, like what led to this new field called as rehabilitation engineering and assistive technology, right? Then we also saw the major activities in rehabilitation engineering, right? So we saw what prosthetics and orthotics are. Then we saw what are the assistive device for visually impaired patients, what are the devices that can be used for auditory impairment patients, then what are the devices that can be used for tactile impairment patients, then for augmentation and communication tools, materials, then manipulation and mobility aids, then recreational assistive devices, right? So these were all considered as major activities in assistive technology, right? Then these are all to give you some examples, right? So this is a what is this? This is an example of what? Can anyone tell what is this? An example of what? Which field is this? Prosthetics. Good, Nancy. Thank you. So this is an example of prosthetics. So I showed few more diagrams like this to give you an idea of what they really are. Right. So this is recreational. This is mobility and mobility aid. Right. Likewise, we saw this different examples. Right. So then, after completing this, we came into another topic called as human component. Right. So human component is applying all these techniques on a human and realizing or learning the consequence of this implementation were considered as human component. In that, we saw these three things, right, which were receptors, processors, and responders, right? uh, this will help you in understanding it much better. First one is sensing part, then processing part, and the output part. Sensing part is the one which senses the environment around us. Processing part is the one which process, in our case the processing part is brain. Output is our movement or the thing that we do in response to certain things, right? So we saw what is processing part, and under that we saw three important functions like perception, cognition, and movement control, right? So we saw so many things, we don't have to go much deeper into that. Please go through all these slides once again, right? So now we will come into our topic which we left with, right? So we were in the middle of 5 misconceptions, right? Okay, so this is where we were at: 5 misconceptions. So misconception is understanding things in wrong manner, right? So when it comes to rehabilitation engineering, there were 5 main misconceptions. Those were uh, put as an outline in this slide. They were solving. People thought that it would solve all the problems. Then few people thought that same device can be used for all the similar issues. Then a few thought it is complicated and expensive, and few thought it should be very accurate and optimal, and few even thought that it can be used always, or it is always used, right? So we saw this assistive technology can solve all the problem. So this is assistive technology is, once again, as we all know, it's just a technology. This cannot solve all the problem. It, as the name says, it can only assist, right? So this we saw in our previous class itself. In the second, this also we saw in our previous class. It says that persons with same disability need the same assistive device. I gave a best example for that, the using of power glass, right? We need, the power glass for every individual differs. Doesn't matter if he has the same power or not, still we may have to use different glasses. The reason is that we only see the power, but there are also some more other, I mean, little more things that we don't see properly. There are something else like cylindrical axis and a few more things like that, right? So it actually differs from one person to another person. Next was, sorry, this is the next one. It says assistive technology is necessary, complicated, and expensive. People neglect this, thinking that it could be very costly. Right, I told an example also about my personal experience. Right, so few people think that it is very complicated and necessarily costly, but the truth is that it's not that costly and it's not that complicated. If it is complicated, obviously the people, the industry people would not market it. The industry people, they will market it only if it is simple and cost effective, right? So that's something based out of their business, right? The next one is assistive technology prescriptions are always accurate and optimal. So few people like they what to say, they don't think it is I mean, most of them think that it is accurate and optimal. Like if you do, we have a single let's take a same example of a power glass. If you wear a power glass, that power glass is not going to be a solution throughout your life, right? Because things could change. There are cases that people um, because of their bad lifestyle, they could decrease their eye power. So in that case, they may have to change their glasses. There are also cases where the eye power retains back to its originality. In those cases, the eyeglasses should be removed or because some other problem. That is what has been put here. It is not accurate. I mean, it cannot always consider as very accurate and optimal. You cannot always go with that single thing as a solution, because the technology changes, the environment changes, the person's health also changes. So we'll have to keep changing it. So the best way would be the manufacturer to treat the person, the one who is taking his product as a partner or stakeholder. Only then he will keep on updating, right? This is why we have updates, software updates in our mobile phone. We don't use our old softwares, right? We keep on updating it to survive the current day scenario. The same thing is applied here in rehabilitation and assistive technology too, right? The next misconception is that uh, assistive technologies will always be used. So actually, there was a survey taken in US which says that about 1/3 of the assistive devices were not needed for survival, which means that after just 3 months they stopped using it. Like let's say a person is given a hearing aid, right? Once he realizes that it's not necessary for his survival, what he'll do is he'll ditch it completely. He will not use it after a few times. That is what is being put here. Assistive technology will always be used, right? So but it is necessary that we'll have to use it as much as possible to keep the person in a proper condition, right? So these are the 5 misconceptions that has been faced by the assistive technology assessment, right? So as I the reason why I went to the first slide is because you have to differentiate between assistive technology and rehabilitation engineering. These 5 things are misconceptions of assistive technology, right? So now we will move into uh, principles of assistive technology assessment. Okay, so previously we saw misconceptions of assistive technology. Now we are going into principles of assistive technology assessment. Okay, so we have some 8 principles. After completing that, we will again go to principles, but not assistive technology, but of rehabilitation engineering. So don't get confused. So what we saw was misconceptions of assistive technology. Now we are going to see principles of assistive technology. In future we'll be studying about principles of rehabilitation engineering, right? So now principles of assistive technology, we have some 8 principles. The reason why we have these principles are you can read from the slide. There's also I've already put this slide once in our previous class also. The difference between physical principles that governs the design and the principle that governs the application. There are some difference. Only if we know that difference, we may able to develop a proper product, right? So all this difference are put as principles, and we will go through each and every principles. As I said, we have 8 principles. Okay, so This is an outline of what are what those 8 principles are. So first one is to have a very specific goal. Okay, you see, I'm telling this as short sentences, but we have a big sentence. We will come to that in the next slides. So we have, as I told, we have 8 principles. First one is define goal. Second one is professional involvement. Third one is user need, then technical consideration, then user preference. You'll have to know the difference between the third point and fifth point. Third one says user need, whereas the fifth point says user's preference. You'll understand it better when we look into it individually. Then sixth one is customization, then training and follow. Okay, so these are all the 8 principles. Now we'll try to focus each and every one individually. Okay, the first principle says that the user goals, needs and tasks must be clearly defined and listed and incorporated as early as possible in the intervention process. Okay, now tell me in which phase we can give rehabilitation engineering. In our previous class we saw 5 different phases, right? You remember 5 different phases in our previous class? We had 5 different phases. Yeah, this 5: shock, realization, defensive retreat, acknowledgement, acceptance. Okay, of this 5, in which stage can we give rehabilitation engineering, or we can introduce counseling or intervention? The best word would be intervention. In which case can we give intervention? In which phase can we give intervention? We have shock, realization, defensive retreat, acknowledgement and acceptance. Number 3 is like a good defensive retreat. Okay, thank you, Sureka. It's actually a defensive retreat, but if you see in defensive, the reason is that this is a phase where people had already been broken down, right? He would have he would try to deny everything, and in this phase only we'll start giving rehabilitation engineering, and this is where we'll have to look into all these things. This principle should be followed. The user's goal, needs and task must be clearly defined, listed and incorporated as early as possible in the intervention process. As early as possible in the intervention process. So in the intervention process, in sense, during the defensive retreat phase, right? In that phase we'll have to look into these things. What are the things we have to look is that the user's goals, the needs and the tasks, right? So a very important thing is that we should not overlook things. We should only see what is necessary for that particular individual. At the same time, we cannot use the same sheet that we have evaluated to all the individuals. That is not possible, because every sheet should be tailored. Everything should be custom made, right? So to avoid overlooking needs and goals, what we can do is we can have a checklist or a form that is already been defined. We can take that form and we can sit next to him, and we can evaluate based on their needs, goals and things. So there are actually a number of helpful assessment forms that are available. We can use it. We even have that in our textbook. I will share it in our group. You can go through it. Okay, so here let me try to explain you through a simple example. Let's say we have a patient. Okay, this patient is paraplegic in sense, let's say he doesn't have one leg and one limb. Okay, in this case we are going to help him by giving an appropriate assistive technology and rehabilitation engineering. Okay, the both terms are actually interrelated, but there are differences. But here what we're going to do is we are going to implement both assistive technology as well as rehabilitation engineering to this particular individual who is paraplegic. Okay, so in that case we have to see this paraplegic individual's goals. We have to see what are his needs. And what will be his needs and what could be his tasks. Any suggestion, any ideas? Any ideas? In our case, we have taken a patient who is paraplegic. Okay, that person here is not having a limb, one leg, one hand. Okay, but he used to be a football player. Now we are designing an assistive technology or a rehabilitation engineering for that particular patient. So now while considering his goals, needs and tasks, what are the tools that can be suggested to him? We saw different tools, right? Major activities in rehabilitation. Under that we saw different tools like prosthetic, orthotics, then we saw recreational, then we saw tools for auditory, visual. In this case we will have to give him recreational materials. We can prescribe him recreational material, and we'll have to be understand his goals, his needs and task. What is his goal? Football, right? Again, he'll though he has broken his limb and he will still like try to do it. So what will be his need? He cannot we cannot transplant a limb. That won't be of much success. But there are things like we can give him a prosthetic. That would be a need. Then task is like, first we will try to make him stand from his wheelchair and take a walk, start walking. That would be first task. First task is standing from, climbing out of the wheelchair. Then the next task could be making him walk. Then what is necessary for him? That is the need. If he needs a crutch, it would be a need. If he needs a prosthetic leg, it would be a need. Then if that prosthetic, we can also, we can fit him a prosthetic leg. That is possible. Then after fitting it, we'll have to train him, right? That is also need. So all this will come under this three things: the goals, needs and tasks. So this must be clearly defined. Okay, so be very careful with this term. It should be clearly defined, right? So we cannot design just like that. It should be clearly defined. That's why in the next statement, in the test work, it is clearly put as, we should not overlook the needs and goals. We should not overlook the needs. He cannot go and play like Messi or Ronaldo. That is not possible. But he can participate in some other forms of football, but he cannot go and play with other players, right? So in that case, we should not overlook the goals, but we have to look at his goals and we have to treat them accordingly, right? So this is the first principle. Now we'll move to the second principle. The second principle here states that involvement of rehabilitation professionals with differing skills and know how will maximize the probability for a successful outcome. Okay, so what do you think is this principle is saying? What is it trying to say? We are going to use the same example, the wheelchair example. A person met with the accident, he lost one limb and one leg and one hand. We are going to use the same example for all the 8 principles. Now here the principle 2 says we have to involve people of rehabilitation professionals with differing skills. The reason is that, see, we are going to design him a prosthetic. We are also going to design for him a wheelchair. We're going to give him a training. So a single man cannot do it. A single professional cannot do it. Let's say we have a rehabilitation engineer. Uh, let's say you, as a biomedical engineer, we've been put as a rehabilitation engineer for a certain patient. So in that case, you can go and help him and develop, we can see him and we can develop a wheelchair, but we cannot give him a training on how to use that prosthetics. That is not possible. That is not our area. We know how prosthetics are made. We know what are different kind of prosthetics, but we cannot give them training. That role will come under, that will be taken care of a chiropractor or the one who has studied physiotherapy. The one who knows about muscles and all those things only will train him, right? So that is a role of another individual. In same wheelchair also, if you take the same wheelchair, as a biomedical engineer, we know anatomy, we know a good amount of electronics, we know a decent amount of computer science, but how much do we know about motors? It's a question mark, right? So in that cases, we biomedical engineers, we cannot go and keep learning about, start learning about motors, and it could take so much time. By the time the patient would have lost his patience and things would get a wrong turn, right? So in that cases, we can use different professionals of different skills. We can use a mechanical engineer, We can ask him for help. We can ask him, like, we are developing this kind of a wheelchair, can you help us with a chassis, can you help us with a motor? If it is we obviously are going to use an electric motor, we can use an electrical engineer, right? So likewise, when it comes to rehabilitation, we'll have to use the skills of differing professionals, of different professionals, right? The same way, like the same patient, uh, he would have been like going through the defensive retreat phase. In that case, in that time, we as a biomedical engineer, we cannot go and console him. In that cases, we need a psychologist, right? Likewise, every individual, like we saw team, the team, we have a session as team of biomedical, I mean team of rehabilitation engineering. You remember, right? In our first unit, we saw a team. We had some 10 to 15, not 10, actually we had some 20 to 30 professionals. So all these professionals will come into play. That is what's been put in the second principle. Involvement of rehabilitation professionals with differing skill is necessary. The reason is that it will help us in getting a better outcome. It will, as put in this sentence, it will maximize the probability for a successful outcome. So very careful, I mean very be careful with this and understand what this principle says, right? Hope you understood it. First principle was to clearly identify the goals, needs, and tasks, and the second principle is to involve professionals from different skills. The third one is the user's preference, cognitive and physical abilities and limitations, his living situations, his tolerance for technology, and probable changes in the future must be thoroughly assessed, analyzed, and quantified. Okay, so here only 6 more minutes left, I guess. Okay, so the principle 3 states that the user's preference should be sought. You have to get the user's preference, right? So the same example, you have to go and get his preference. You'll have to know his cognitive and physical abilities. Like, see, if you I told he used to be a football player, right? So the football player also, like in cricket we have a batsman or someone who is very specialized in batting, specialized in bowling. Likewise, in football also we have different like special qualities, like forward, mid, backward, I mean goalkeeper, wing, and so many such things are there. We have to know his physical abilities. We have to know if he's really good with his right leg or left leg. We have to know if he's really good with this. If he has a good goal score, if he has a good goal scoring capability using his head or using his limb, or if he is a good defender, we'll have to know all his physical limitations, physical abilities. Right? Then we'll have to know through what kind of situation he is living through. Then we have to know the tolerance of technology. So this is very important part, and this is the part where we biomedical engineers have to take extra care. Tolerance for technology, right? So tolerance for technology, in sense, try to give us different example. If you see patients who have pacemakers, they will not be allowed inside MRI ward, right? You would have heard that patients with pacemaker will not be allowed inside MRI ward. The reason is because pacemaker is a metal which is kept inside your heart, right? So if we send a particular patient inside an MRI machine, what will happen? The magnet will try to suck the pacemaker. So it could be very lethal, and it could even lead to the death of that individual. So considering all those, we'll have to see different tolerance for technology. The individual that we are going to, let's come back to our previous example, the football case. In this case, if that particular individual with a broken leg already has a metal in his leg, means we cannot give another technology there. We cannot give him another prosthetic there, because already he has a metal in his body, right? So it could cause some other problem. So this all should be considered, the tolerance for technology, and all those to be considered, and the probable changes in future should also be taken. We have to know the future, the changes that could happen in the future. Like we will be giving all rehabilitation engineering, we will be giving him support, we will make him play football, but will he continue playing football? That remains a question mark, right? So we'll have to see what are the probable changes in the future, not in like his mental state, but also in the technology we have. So now we may not have a better technology, but in future we may get very good technology that could replace his complete he can go and play football properly, right? So that could also be possible. So we'll have to be very aware of the probable changes in future. So all this should be thoroughly analyzed, assessed, analyzed, and quantified. Right. So this is the principle number 3. Right. So first one was to know his needs, goals, and task. Goals, task, and need. Then second one was to involve rehabilitation professionals of different skills. The third one is user's preference, his ability, and technology tolerance, and the changes in future. Right. So now we'll move to the fourth one. The fourth one says we have careful and thorough consideration of available technology for meeting the user's needs must be carried out to avoid overlooking potential useful solutions. Okay, so this is very important. I'd like to tell another example here. You all know about MRI machines, right? So how we rate an MRI machine is that based on its power capacity, the Tesla power we say, right? A basic MRI machine would be 1.5 Tesla, then comes 3 Tesla, then comes 5 Tesla, then 7 Tesla, like that. It keeps on increasing. So based on this power, the rate of the machine also varies, right? So for a normal individual, for a normal scan, a 3 Tesla would suffice. But what happens is that few people, they will try to they will buy 7 Tesla, which is actually not needed for most of the cases, which is necessary only for research, but they will try to use that, right? So that is not necessary, right? Though it is a very high-end technology, it's not necessary. A simple one is enough, right? For a fracture, it is enough to use X-ray scan, right? We don't have to go through MRI scan. A simple X-ray scan is much better. Much cheaper and effective also. Right? That is what has been mentioned in this. We have to be very careful while selecting the technology to meet the user. Right? The user should be treated properly with appropriate technology. Just because we have a very high-end technology, we cannot implement it on the patient. We'll have to choose the ones that is best needed for that particular individual. Right. So that is why it's put. It should not. You should avoid overlooking potentially useful solution. The one that is correct, or the ones that apt, which should be used on that particular individual. Right. So these are the 4 principles. We have few more principles which we will see in our next class.